Hello, everybody, and welcome to lesson 5.6 in our textbook. It's on page 306, and the lesson is on trapezoids and kites. Okay, today we're going to learn about properties or descriptions of trapezoids and kites. And over here in the middle of the page, let's read this together. You can underline it. We're talking about angles, sides, and diagonals. The diagonals are the ones that go across. So three things you have to keep separate of a trapezoid have certain properties or rules. You can use the word rules. A trapezoid is a quadrilateral, which is a four-sided closed figure with exactly one pair of parallel sides. So these are the two parallel sides. This is a trapezoid. Yeah, one pair, not like a parallelogram that has two pairs. The parallel sides of a trapezoid are called bases. So this is base 1, base 2, right here. And again, you can see the little arrows that indicate parallel sides, parallel lines, okay? The non-parallel sides are called legs. So this is a leg. Oh, I'm not going to color that in. This is a leg right here, and this is a leg, okay? The two angles that share a base of a trapezoid are called base angles. There's two pairs of base angles, one here, and one up here and here. So these go together and these two go together. They're called base angles. And now we're talking about a special trapezoid, which is called an isosceles trapezoid. Legs are congruent. So the bases are this and this. They're not congruent. They're not the same length. They're just parallel, but the legs, these two are congruent. Do you see the tick marks? Okay. ABCD at the right is an isosceles trapezoid. The angles of an isosceles trapezoid have some unique properties or rules. So the base angles and these two angles, they have some properties, and what they are explains right here. So if you have an isosceles trapezoid where this is the base, these two are the bases, then the base angles are congruent. Like angle T and angle P are congruent, and angle R and angle A are congruent. Doesn't mean they're congruent to itself. It's just two pairs of congruent angles. So this right here is our first theorem. Make sure you always highlight this to go back and look it over when you do your homework. So that was page 306. Then we are, nope, made a mistake. We're staying on this side. We're now on page 307, the top. Okay, finding angle measures in trapezoid. Look at the picture. It's tilted sideways. So it's still two bases. These are the bases, and these two are the legs. It's just flipped up. Do you see? So you take the original one and it was 90-degree turn. So these two legs are congruent. So it's an isosceles trapezoid, yeah? And they're giving us one angle. This is an angle. Measure of angle R is 106 degrees. So of course we have to find all the other angles, right? Angle P, angle Q, and angle S. So again, make yourself familiar with the picture and understand what it is you're looking for. Are we looking for a side or an angle? What do you know about the angles of an isosceles trapezoid? We just read it on the previous page. It said that each pair of base angles are congruent. So that means that this and this is the same. These two are base angles because remember it's flipped up, and this is the same. These are the base angles. If you tilt it down, it'll be the right side up. It'll be the base actually, okay? So here's the clue what we're going to do. First, we're going to find the sum of all interior angles. You might already know it because you've done homework on a previous lesson where you had to find the sum. And you remember the triangle was 300, the triangle is always 180, and maybe you already know that a quadrilateral, the sum is always 360. It's four-sided, 1, 2, 3, 4. So n is 4. 4 minus 2 is 2 times 180 is 360. Use your calculator to verify. So this, you often have to find the sum because we need to know what they add up to. Well, I know this one is 106 because they're equal, right? Measure angle S, I can already write it here, is 106 degrees. And their sum has to be 360, and these two are equal. So if they're equal, I will choose to call them X and write an equation. You can reason it out other ways, trial and error, use different numbers, that's fine. But my thought is that if I say this plus this plus this plus this has to equal 360. So I'm going to do that. I'm just going to add all these what I got and write an equation, yeah? X plus 106 plus 106 plus X has to be the sum, has to be 360. Now I'm going to combine like terms, 2X and 106, and 106 is 212. I'm looking for X, which is that angle, right? Oops. Minus 212 on both sides. 2X is equal to 8, 5, 1. Divide by 2. 158 divided by 2 is, I believe, 79. 74, 70. It seems like I made a mistake somewhere. 360 minus, I need to use a calculator. Minus 212. 148. There's my mistake. Yep, I didn't carry a 1. So 148, now I got it. It's 74. I worked this out earlier. So 74 degrees is both of these angles, right? I call them X. If you have tried trial and error, see which way is faster. Sometimes this is faster, sometimes trial and error is faster. So now we have measure angle P, 74, and measure angle Q is 74. And we know that if we add all 4 of these, the sum has to be 360, like in any closed four-sided figure. And it is. If you want to check it out, you add, and it'll come up to 360, which is great. Then we got it right. Okay, so that is that question. By the way, if it's an isosceles, trapezoid, you only need one angle known to start with. If it's just a regular normal trapezoid, not these two are congruent, then you need 2 angles. So 1 angle is all you need in an isosceles trapezoid. 2 angles is what you need. Is it 2 or 3? I think it's even 3. I'm going to have to think about that one. 2. Do we need 2? Let me look at the previous page. Does it say anything? Nope. Then we need 3. 1, 2, 3 to find the third one. Yeah. Okay. Yep. I think we need 3 if it's just a regular trapezoid. Okay, on this page, I'm pretty much done. So that was page 307. Let's go to 308. And we'll go to the bottom of that page. There you are, another take note. Let's see what this one says. It says, if a quadrilateral is an isosceles trapezoid, then the diagonals are congruent, meaning same measure. But it has to be an isosceles trapezoid. And what makes it isosceles again? The legs are congruent. The bases are parallel. The bases, the top and the bottom, do not have to be the same length. You notice this one is shorter than that one. If it was the same length, we would have a rectangle. But the bases are different length, but parallel. The legs are the ones that are congruent. That makes it an isosceles trapezoid. Now, if we add the diagonals, which are the ones that go across, now we learn that the diagonals are congruent, meaning they have the same length. It doesn't say anything about that they're bisecting each other or cutting each other in half, or they're bisecting any angles, or that they're perpendicular. All it's saying is that the length from here to here is the same as the length from here to here. That's all this is saying. In lesson 4.1, you learned about midsegments of triangles. Trapezoids also have midsegments. The midsegment of a trapezoid is the segment that joins the midpoints of its legs. The midsegment has 2 unique properties or rules. Let's go to the next page, 309. There it is up here, trapezoid midsegment theorem. So we always want to highlight these, make sure we always look back on these. If a quadrilateral is a trapezoid, indeed it is, look at it. The midsegment, this is your midsegment. Where do you get it from? The middle of this side to the middle of that side. That's the connection, yeah? The midsegment is parallel to the bases, so that means they're all parallel. Parallel, parallel, parallel. And the length of the midsegment is half the sum of the length of the bases. Well, so here's what we do. We add the bases, add the length of bases, and divide that answer by 2. That's how you find it. This means divide by 2. Add the bases. So I'm going to give you a quick example here, just to get you an idea what this conglomerate sentence means. Let's say this base is 10 and this is 6. How do you find this length? You add 6 plus 10 and divide that answer by 2. 16 divided by 2 would be 8. So this would be 8. That is the relationship. Okay? This looks super duper complicated, but that's how math books write it. When you get more experienced with math, you would be able to read that, and you still are. MN is parallel to TP, and MN is parallel to RA, so they're all parallel, and MN is half of the sum of the bases. That's all it means, half of the sum of the bases. Anyways, let's practice on our first problem here. first of all, it sometimes asks, how do you check your answer? You plug your answer you get for X or Y or Z, whatever the variable is, back into expressions in problem. These are the expressions right here. And then you compare and make sure it works out. And make comparison, I should say. So you kind of check. Remember up here, I had numbers in 6, 8, and 10. I had to remember that 6 plus 10, that this is half of the sum of these two, and it is. So that's what we have to do with this as well. This is your midsegment. Mn is the midsegment of trapezoid PQRS. PQRS. What is X? What is NM? There's two questions here. Sometimes we answer the first question and forget about the second. So we always want to make sure we look at that. Okay, so look. Remember I said the sum of the bases, which are on the outside, these are the bases, divided by 2 is the midsegment. So the bases are the ones that hold the shape together, the top and bottom, if it's sitting the right way. These are the bases. This is your midsegment. So the sum of the bases, so the sum, I'll start with the 10 plus, the order doesn't matter how you do it, x minus 12 is equal to the midsegment. Oh, divided by 2. The sum of the bases divided by 2. Right, sum of the bases, that plus that divided by 2 is equal to the midsegment. So there's our super duper equation. First, I'm going to get rid of the 2 by multiplying both sides by 2. Got to put parentheses around it. This cancels. So 10 minus 12 is negative 2 plus 8x is 2 times 2x is 4x. 2 times 11 is 22. So you're multiplying everything by 2. That's a quick way to clear that fraction. And now we're going to, I'm going to start with the x's, subtract them from both sides. 8 minus 4 is positive 4x. And then add 2. I'm going to bring that up here. 4x equals 24. 22 plus 2. Divide by 4, it's 6, right? So we found x. So that's the first question. 24 divided by 4 is 6. What is x? X equals 6. Now we have to find mn. So 2 times 6 plus 11 is 12 plus 11. 12 plus 10 is 22, 23. Right? Did I do that right? 12 times 6, x is 6, is 12. 12 plus 11 is 23. Now, before I want to stop, I want to see if we can check our answer. Not that we really have to do that each time, but sometimes it's worth it. We want to get the relationship right. So x is 6. So this is 10. 8 times 6 minus 12. 48 minus 12 is 38 is 36. And this was 23, right? because we already found that. 8 times 6 is 48. 48 minus 12, I believe it's 36. Let's try it. 10. So the sum of the bases divided by 2 should be 23. 10 plus 36 is 46 divided by 2. Yep, that's true. They all check out. So this is how you can check. And look at, you know what, if this is a lot of stuff, I would not even copy it as I'm watching the video. You can copy it and then watch it one more time, just this part, rewind, to kind of make sense of it. It really needs to be made sense of rather than just copying, unless you understand every single word I'm saying, okay? And I was looking at this one. How many mid-segments can a triangle have? So a triangle has mid-segments. So they start from one middle to the other middle. So there's one mid-segment, but you have one from here to here as well. There's another mid-segment. And then you can have one from here to here. So it can have 3 mid-segments. But a trapezoid is different. A trapezoid is kind of limited with those mid-segments because the mid-segment only goes from leg middle to leg middle. So they can only have one. The mid-segment does not go from the bases to the bases. It starts at one leg and goes to the opposite leg. Always starts in the middle. So it can only have one. Yeah. This was page 309. Now we're on 310. In the middle of 310, now we're learning about a kite. A kite you've all flown, hopefully, at the beach maybe. A kite is a four-sided figure, quadrilaterals, with 2 pairs of consecutive sides congruent. So look, this is congruent to that, this is congruent to that. They're not congruent to each other, nor are they parallel. They're not parallel. Nothing here is parallel. The only thing that's congruent are the sides that are next to each other, consecutive. So consecutive always means something is next to each other, right? There's nothing in between. So this is congruent to that. So if this is 5, this is 5, and then this could be 7, and then this must be 7. And it's not even doubled or half. There's no other relationship. The angled sides and diagonals, again, same thing. We're talking about 3 different things. Keep them separate in your mind. Of a kite have certain descriptions, rules, significant parts. If a quadrilateral is a kite, then the diagonals are perpendicular. That means they meet at a right angle. So from here to here is one diagonal, and from here to here is the other diagonal. They're not cutting each other in half. They do not bisect each other. They do not bisect, and yes, they do bisect the angles, these two, and I'll show you later why. All this is saying is that you got one right angle. That means you got 4 right angles here, perpendicular. So that means they meet at a right angle. So this is the symbol for perpendicular. And if I'm going to blow that up for a second, I want you to see that if you have one right angle, that means you got really 4 right angles. But in math, we only use the minimum necessary to show something. So we only draw one. And it's understood that all 4 are right angles. Okay? And my perpendicular sign looks kind of sad. So I'm going to make that nice and straight there. Okay. So make sure you read that. Highlight. Read it over when you do your homework to look for clues. Next page 311, we're on top. Finding angle measure in kites. So there's our kite, quadrilateral KLMN. KLMN is a kite. What are measure 1, 2, and 3? So we know 1 is a right angle. That's the perpendicular. Those are the diagonals. And the diagonals we just read meet at a right angle. So I'm just going to write that down right away, 90 degrees. Okay, this one here is 36. So first of all, I know 3 is the same, and I'll show you why. If you remember isosceles triangles, which these are this is an isosceles triangle. I'm going to make it red. So you see it. This right here is an isosceles triangle because these two are equal, right? These two sides are equal in a kite. But that was our description of a kite. So let's look at that. So this right here, so in an isosceles triangle we learned these two legs are equal. If we have a perpendicular bisector, which meets down here at a right angle, it cuts these two angles, this angle in half. That's called a perpendicular bisector in an isosceles triangle. Perpendicular angle bisector. Isosceles triangle. I should look it up what page it is. I'm going to see if maybe later. So that means that I now know that this is my perpendicular, because it's a 90-degree angle here, my perpendicular angle bisector. That means it cuts this angle in half. So now I know that the measure of angle 3 is the same as this one, which is 36 degrees. I'm going to erase all that. Too much mess. So 36, 36. Now I got to find this one. So this triangle right here, I will write down a little bit bigger. This is also a right angle. Because these are the perpendicular diagonals. So this is a 90-degree angle. This one is 36 degrees. What leaves you, what is this one then? So remember, we can, you can add these two and subtract it from 180, or you can reason that the sum of these two has to be 90 because this is 90. So that leaves 90 degrees for these two. So I can just say 90 minus 36, skip one thing, or you can say 36 plus 90 and then subtract your sum from 180. That's another way. But I'm choosing this one, it's simpler. 6 to 10 is 4, 1, 4 to 9 is 54 degrees. So that one up here is 54 degrees. Okay, now if this right here confuses you, if you're like, what, she's never done that before, I'll do it this way. 36 plus 90 is 6, 9 plus, so it's 126. And then 180 minus 126. 6 to 10 is 4, 1, 3 to 8 is 5. It's the same number, notice. Okay, this is shorter. So now we got all our answers. What are measure 1, 2, and 3? 1, 2, and 3. Yep. Okay. Let's try this one. This is cool. I'm going to find each and every angle in this kite, and you can too. Notice it's a kite, right? First of all, they tell us it's a kite, and second of all, I can see it by saying this is the same as this, and this is the same as that, and that makes it a kite. These are the diagonals, and I also know that the diagonals are perpendicular. 1, 2, these 4 angles are all 90 degrees. So that's already saved me a lot of work. So I'm going to start. So notice you have 4 triangles. 1, 2, 3, and 4. So your tool is to say this is 180, the sum, this sum is 180, this sum is 180, and this sum is 180. So each triangle has to add up to 180, and you always know 2 angles, so you can find the third one. This is 90. I'm going to focus on the top triangle right now, this one. So I need to find this angle. I know this one, and I know that's 90. So it's 34 plus 90 is 124 subtracted from 180. $56. So I'm going to write them all out here. Measure angle, I think that was 1, is 90 degrees. Measure angle 9 is 56 degrees. So I'm done with this triangle, correct? So now I'm going to the next triangle, this one right here. Okay, so like right here. I know measure angle 2 is 90. And then measure angle 10 has to be 90 minus 46 because I'm just doing the shortcut. I know the sum of these two has to be 90, so I'll just do 90 minus 46. Save me a step. 1, 5, 5 to 9 is 44. Why do I have a different answer? 40, yeah, it's 44. 46 plus 44. Yep. Okay, so I'm done with this triangle. And I'm moving down to this one. Measure angle 4 is 90. That's the right angle. 5 is the same as this because this is an isosceles triangle, this big one here. This right here is my isosceles triangle, and I know these two are equal because this is a perpendicular bisector. So measure angle 5 is 46. And I know measure angle 8 and 5 add up to 90. So 90 minus 46 is 44. Oh. Sometimes my computer goes haywire. So what are we at? Measure angle 8, right? That's this one was 44, I think. Yep. So done with this triangle. Now moving on to the last one. Measure angle 3, I know is 90. That's your 90-degree angle. 7 and 8 are equal. So measure angle 7 is the same as 8, which is 44. And 6 and 34 are equal. Measure angle 6 is also 34 degrees. Now I have solved every single angle in this kite, correct? And so can you. Page 311, and now move to the next page, which is a super good problem. This right here is nice, and I want to talk about that. This is called a hierarchy. A hierarchy is like a family tree. And the word hierarchy is H-I-E-R-M-A, hierarchy. Greek, hierarchy. So it starts up on the top. The top, think of a family tree. The top is the great-grandfather of this family of quadrilaterals, four-sided figure. He's called quadrilateral, right? He has certain properties, and he has passed them on to his offspring. Think of these as his kids' offspring. So he had the kite, which really is all by itself, nothing else like him. He doesn't have any more offspring either. Then in the middle here, the trapezoid comes from the quadrilateral, and the trapezoid has a special isosceles trapezoid. So this is one branch of the family tree. And then over here, the quadrilateral is the great-grandfather of the parallelogram, and the parallelogram has all these little offspring. We have the rectangle, the rhombus, and the square. The square is on the bottom. So when you look at the hierarchy, you work your way up. So what that means is that all of these are quadrilaterals, right? Because it's all from the same family tree up on top. But the square is the lowest one on the branch. It is the most described. It has all these special little things. A square is a rectangle, but a rectangle is not a square. So it goes up, but not down. A square is also a rhombus. It has the very same properties as a rhombus, but it doesn't go backwards. A rhombus is not a square. A square is also a parallelogram, so you work your way up. It has all the same properties that we learned about parallelograms, also the square, but it doesn't work its way the other way. A parallelogram is not a square. And all of them are quadrilaterals. So over here, so these are separate. See how they come from one? They have their own little properties, but these do not mix with those. So the isosceles trapezoid is way on the bottom. It is called a trapezoid and also a quadrilateral. My thing is starting to give out, but it doesn't work the other way. A quadrilateral is not an isosceles trapezoid. Yeah, and then there's the kite. They have nothing much in common besides being a quadrilateral. The kite has its own rules. There are only those two sides that are equal. So the way you can see that is that you work your way up, but you cannot. So I'm going to write that here. A square, just for example, a square is a parallelogram because it works its way up. It's under the family tree. But a parallelogram is not a square. Ooh. And that's called a classifying. You can name these going upward. It's called classify. When you hear the word classify, it's called naming. Okay, so that right here, sometimes you'll see. Okay, just to show you this. And now on our homework, what are the measures? This is a kite. Yeah, this is a kite. You got to find the angles here. And then number 10 is a trapezoid. Oh, you know what? I told you a lie. I said you need 3 angles if it's not isosceles. You only need 2. There must be something I'm missing. Got to think about that. So I was thinking for a minute, but it doesn't click what I'm missing here, why we only need 2 angles. Opposite angles are not congruent. They're not congruent, opposite angles in this. And it's not a parallelogram. It doesn't fall under the family of parallelograms. So that would mean that opposite angles are congruent, consecutive angles are supplementary. I'll have to see. When we get to this part in our homework, by then I have to have solved the puzzle, which eludes me right this moment. So number 11, this is about the midsegment of a trapezoid. So remember that theorem about the midsegment, look it up. Next page, number 12 is a kite, a parallelogram. And I want you to look at the chart on the left that we just looked at and see if they're in the same family tree underneath, yeah? And then you can explain yes or no. Compare and contrast, how is a kite similar to a rhombus? So you need to look back in the previous lesson and look at rhombus properties. Okay, rhombus. How is it the same and how is it different? And then come up with some of those. And there's an error somewhere in this thinking. Since a parallelogram has 2 pairs of parallel sides, it certainly must have 1 pair of parallel sides. Therefore, a parallelogram must also be a trapezoid. What is the error in this reasoning? You could also look at the chart on the left side of the page or come up with your own reason. Think about a plan number 16. The perimeter means you add all sides, side length. That's what perimeter is. And so it says here, the length of one of its sides is 3 centimeters less, which is minus, than twice the length 2 times. Twice is 2 times the length of another. Find the length of each side of the kite. Can you draw a diagram? How can you write algebraic expressions for the length of the side? So I'm going to get you started, see if you can finish that. It's a kite, so I'm going to, of course, draw some kind of kite contraption. These 2 are congruent and these 2 are congruent, correct? I do not need the diagonals. It's talking about the outside, the perimeter. So it's this plus this plus this plus this, okay? And then if you call one side x and then that side x, then you need to write an expression using x in the other side. And the clue is right here. 3 centimeters less than twice the length of another. So you have to write an expression for that. Then you add them all up and set them equal to 66. Okay, I'm going to let you think about that. And this page, we're on page 314. There's your algebra questions where you have to solve equations. I picked number 19. This is an isosceles, so base angles are equal. These 2 are equal. That's your equation. This right here is your midsegment. Midsegment. Look up the formula again. The sum of the bases divided by 2 gives you the midsegment. So there's a lot of equations, so you have a little room. You might want to find some spot where you can work these out. And number 24, find the value of the variable. That means you have to set up equations. Focus, this is a kite. This is a right angle. Focus on one triangle at a time. Focus on this triangle. This is 90 plus this has to equal 180. And once you find x, plug it back in here and you find that angle. And then this is a real life problem where you can find some kind of shape that looks like a trapezoid, right? So the beams of the bridge at the right form a quadrilateral. That's this right here, four-sided figure. And then they give you these little clues. Triangle, the triangles here. This one, triangle 1, triangle 2, triangle 3, those are this. They're all congruent to each other. That's the clue. And they're giving you an angle measure. I'm going to use green. That looks really good on black. They're giving you one angle, and it says measure angle DCB is 120. DCB. So this angle is 120. Find the measure of the other interior angles. So you have to find this one, and this one. Okay, classify the quadrilateral means name it. What kind of shape is it? And why? And I think that's it. Yep, that's it. Thank God, right? So good luck on that, guys. See you in class.